All right, so in this video, I'm going to be taking the derivative of arctangent of x. It's pretty straightforward, like arc sine and arc cosine follows the same steps. So to start, I'm just going to use implicit differentiation, and I'm going to take the derivative of both sides. Up here in the top left, I wrote tangent of y equals x. That's what I'm going to be taking the derivative of both sides of. So that's just going to be d over dx of tangent y equals d over dx of x. And of course, the derivative of tangent of x itself, or tangent of y, anything, is just going to be secant, and then secant squared. And then using the chain rule, we get dy over dx multiplied to that. And then, of course, the derivative of x itself is just going to be 1. And then we're wanting to isolate dy over dx because that's what y is. We're taking the derivative of y here to get this derivative of arctangent of x. So we're going to just be left with dy over dx is equal to 1 over secant, it's a terrible e, secant squared of y. And we want to write this in terms of x. And the first thing we need to do here is look at our trig identity, the Pythagorean trig identity. And it's not as straightforward as how we're going to get secant squared, but hopefully you should be aware of dividing every term in here by cosine squared, and that will actually get us what we need. So if I do that, this first bit over here, sine squared over cosine squared is going to be tangent squared, plus cosine squared over cosine squared is just going to be 1. And then 1 over cosine squared is going to be, well, it's going to be secant squared of y. And then I'm going to actually want to start isolating the secant squared. So what we're going to do, it's actually already isolated for me, so that's fine. And I don't need to take the square root because it's already squared, and both of these are squared. So it's a little bit easier than cosine and sine, or well, the arc cos and arc sine ones I made already. So that's neat. And then moving forward, I can just substitute it in, and I will say dy over dx is equal to 1 over all of this, which is just going to be tangent squared of y plus 1. And then if we look up here, tangent of y itself is equal to x. So I can rewrite this as dy over dx is equal to 1 over x squared. Fix that x squared plus 1. And that's the derivative of arctangent of x. And I went ahead and got the graph of arctangent of x down here in the bottom left. And it quite literally is one of these kind of segments of the tangent function rotated, or not rotated, reflected across the y equals x line, which is going to be this line right here. And so that itself, it makes sense why it looks like this, right? And of course, you can't have another one stacked on top of it because then it won't be a function anymore. But it's fully continuous across its entire domain, and it's defined between the interval negative infinity to infinity, right? So it's not like there's any restrictions on this. But I want you to look at what it is approaching in terms of this y value. It does have a horizontal asymptote. It actually has 2 of them. It has 2 horizontal asymptotes. One of them is at pi over 2, and one of them is at negative pi over 2. And you should recall that that is where the vertical asymptotes of tangent of x is, which is going to be pi over 2 and negative pi over 2, or any multiple of that, right? Because tangent would continuously repeat. So it'd be pi over 2, and then pi, and then so forth. Or, well, not pi, but it would repeat. Hopefully you understand what I mean by that. But the way we can kind of visualize this is if we were to take the limit of arctangent of x, of course we can evaluate that head on, but we know that tangent is sine over cosine, right? So if we are saying that this is going to be approaching some value, to where it has a horizontal asymptote, right? As x is approaching infinity of arctangent of x, this y value is approaching some value here. And in a way, we could say that if x is approaching infinity of arctangent of x, then that means that tangent of, if we look up here, right, if arctangent of infinity is equal to y, then tangent of y is equal to infinity. So we'd be solving for some angle here. And the only angle where we'd be approaching some infinity value with tangent is going to be pi over 2, for example. There's more than that, but pi over 2, which is where we would have something like 1 over 0, so not quite pi over 2, but just before, where we have something like 0.9 over something like 0.001, right? That would be approaching infinity as y is approaching pi over 2, or as it is approaching negative pi over 2. And you can see those asymptotes here at pi over 2 and negative pi over 2. Those are the points at where cosine is approaching 0, but sine is approaching 1 or negative 1. So you can kind of see that here in the asymptotes. It's kind of visual there in the arctangent of x function. So I hope that was useful for you to interpret the graph a little bit, as well as, of course, getting the derivative of arctangent of x.